hopefully you've had an opportunity to work through this example problem on your own. I'm now going to go through a more detailed solution of it. So here we are looking at an acid dissociation reaction. And what we need to do is calculate the acid dissociation constant so we can evaluate if this is a strong or a weak acid. And we've been given equilibrium concentrations for each of our reactants and products. And we know the equation. So we have our acid, which is hydrogen cyanide, and our base, which is water, which means we're looking at a dissociation reaction. And our conjugate base is going to be our acid, hydrogen cyanide, minus that hydrogen, so Cn minus. And my conjugate acid is my hydronium ion. So to set up my equilibrium expression, my Ka is going to be equal to my product concentrations divided by my reactant concentrations. Remember, I'm going to ignore the water because it's also my solvent. So for this reaction, my products are cyanide and hydronium ion. And they each have a coefficient in front of it that's emitted, which means it's 1. So I have exponents of 1 that I can just ignore because it'll just be itself. And on my reactant side, the only one I need to consider is the hydrogen cyanide, the HCl. And it also has a coefficient of 1. So now I can plug these values in here into my equation. So my cyanide concentration is 4.9 times 10 to the negative 5th molarity. My hydronium ion concentration is 4.9 times 10 to the negative 5th molarity. And I'll divide this by my hydrogen cyanide, which is 5 molar. Now, plugging this into my calculator, I get 4.8 times 10 to the negative 10. The units on this are, we usually report K as unitless, so you can just report the number. So here's my value. Now the question is this a strong or a weak acid? So because this is times 10 to the negative 10, it's a very small number. It's much smaller than 1. Therefore, this is a weak acid. I don't expect a lot of my acidic hydrogen bonds in my hydrogen cyanide to break to form cyanide and hydronium ion.